In this video, we're going to give you an introduction into getting started with the technology database. The TechDB is the intelligence in the system behind the knowledge-based machining strategies and is responsible for the ability to create automatically generated toolpaths in both SOLIDWORKS CAM and CAMWorks. It can be accessed in different ways. Without a part file open, this is best done through the Tools menu within SOLIDWORKS. The TechDB accommodates all users with the ability to define all elements for both metric and imperial units. The switch between the two can be done in the top corner of the dialog window. Regardless of which units the user is working in, they will have the ability to define new machines, tools and tool cribs, strategies, as well as editing libraries controlling the default materials and feeds and speeds. In this video, we will focus on working in metric units and guide you through the creation of a tool, adding this tool to the tool crib, and addressing the workflow to add in further elements to the database. The definition of tools is broken down into both milling and turning tools. Focused on milling tools, we have access to a wide selection of tool types, ranging from end mills, tapered mills, drilling tools, form cutters, and the ability to custom define these shape tools, as well as threading tools. The default database provided during the install already contains a large selection of tools, which can be used as well as added to. The easiest and most efficient way to adding a new tool is to simply copy a pre-existing tool and modify the parameters to suit. In this example, we will copy the existing 16mm ball nose cutter and define the new cutting parameters. Furthermore, feeds and speeds can also be set specific to the tool, as shown here. When defining the operation within the setup of a CAM part, the feeds and speeds can be driven by one of three ways: the tool, the default feeds and speeds library within the TechDB, or modified specifically for the operation defined. The tools can then be predefined with a holder in the Assembly Tools section of the TechDB prior to adding them to the tool crib. The tool crib can then be set to specify the use of these pre-assembled tools. Alternatively, they can be built within the tool crib itself. Simply add the tool, define the holder, and set the station number to match the tooling on the machine. Similar to tooling, the machines within the TechDB can also be duplicated with ease. Simply copy a predefined machine and adjust the parameters to suit. Here we can set the machine name specific to its manufacturer, make and model, define the default post processor to match the controller of the machine, along with defining the kinematics of the machine with respects to table travel, spindle speed and turret setup, defining the default tool crib to use from those defined within the TechDB. Default strategies specific to the different features extracted from the CAD model are also hosted in the TechDB. Each of these feature types are listed and can be automatically applied to the model during the feature recognition stage of the CAM model setup, significantly increasing your efficiency and reducing the time from design to manufacture. Multiple strategies can be assigned to each feature, with the build-up of the operation linked to the strategies defined below. These strategies and operations can be added directly to the TechDB using the data entry fields. However, a more efficient way to build up your library of strategies is to apply these directly to the CAD model and then save the operation to the database. This allows for the toolpath to be visualized and tailored to your needs. To see this workflow in action and how to use all the features available in the CAM package, check out our training courses listed on our website. feeds and speeds section of the database allows users to add materials to their already defined list of material, as well as set the feeds and speeds based on the material cutting conditions. Once a material is added to the database, the user can proceed with defining the feeds and speeds for this material, relative to the cutting depth of the tool, the operation type, and the material it is applicable to. The user will then have the ability to use these parameters to drive the definition of the toolpath when applied to the model, as previously mentioned. The functionality of the TechDB is extremely powerful, and the transition from design to manufacture has never been easier. Additionally, the TechDB can be shared between multiple users to ensure the consistency across the manufacturing team and all engineers. The TechDB can be stored locally to individual computers or stored centrally for multiple users to share. As a follow-up to this introductory video, and to find out more, check out the other videos on our website, explore the training courses we offer, or contact us on the support desk.